All right, let's talk about branched alkanes. So we figured out how to name just regular alkanes, right? Just straight chain alkanes. But what if we had something like this? Right, now we have this little branch down here, right? This little branch there. And so the first step in these problems is to, number one, find the parent. And so this is going to be the biggest chain. The parent chain is the biggest chain. And so if you count the biggest chain here, it's going to be this compound right here. And so that's your parent chain, and everything else is a substituent. So this is a substituent. And then in the orange is the parent chain. Let's see another example of this. So you got to be careful with this stuff, right? If you're thinking about the parent chain, it's not this one, right? That's not the longest chain. Just because it's not drawn that way doesn't mean that it's the longest chain, right? The longest chain is actually right there. And then that's actually the substituent. So you need to be able to identify the longest chain. And so we can name these compounds by naming the parent chain and then naming the substituents. And so for these alkane substituents where we have all just carbon-carbon single bonds, they're called alkyl substituents. And they get the suffix of -il, right? -il. So for example, if we have this substituent right here, it's one carbon, meth means one, and then it's a substituent, so it gets -il. So this is a methyl substituent, methyl substituent. If you had something like this, where now it's 2 carbons long, F means 2, and then -il, it's a substituent, so this is an ethyl substituent. And so the way this naming structure goes, it goes the location of the compound by numbering, what the substituent is, and then the parent chain, and then any kind of suffix that you need to add on the parent chain. For now, we won't really use that as much. But let's check this out. So if we had something like this compound right here, the first thing we would do is identify the parent chain, and we can see that the longest chain is here. And if we count the carbons, 1, 2, 3, 4, 5, 6, we see it's 6 long. So this is called hexane, right? So this is the parent and then the suffix, right? The parent is the kind of hex, the suffix is the ane. And so next step we need to do is we need to identify the location and what the substituent is. We can see that this group right here is on the 3rd carbon. And so this is 3, and we can see it's a 1 carbon group, a 1 carbon alkyl chain. So that's meth-il, right? So this is 3-methyl hexane. You have to be a little bit careful. Think if you counted the other way, right? If I do this 1, 2, 3, 4, 5, 6, right? Could I call this 4-methyl hexane? And the answer is no, you cannot. That would be the wrong name for it. So according to IUPAC standards, we always keep these numbers as low and as possible. And so you can see how there's all these kinds of little cases where you can come up with different variants. And there's a lot of little rules that you would need to know for naming, but we're only going to go the other way, so you don't have to worry about it as much. You still have to worry about it a little bit, but not as much. Let's check out another variation of this compound. Again, we can identify the parent chain. In this case, we have 1, 2, 3, 4, 5, 6, 7. 7 is hept. And then they're all carbon-carbon single bonds, so it's heptane. And then we have 2 of these methyl substituents. And so we have 2 of them. What we can do is add yet another prefix, and that prefix is di. So this is dimeth, right? 2 different methyl groups, dimethyl. And then we, of course, need to add the location, 3-dimethylheptane. And so you can do di or tri. Next up, what if we have branches upon branches, right? So let's take a look at another compound. And then up here, we'll put another branch here, and then another branch on top of our branch, right? So the first thing we need to do is identify the parent chain. Let me just make this a little bit longer. Right, so this is going to be your longest chain. Let me add one more there. That way it's the longest chain. And so we can count the carbons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you don't have to know the name for this one, but this is undecane. So the parent chain here is undecane. I won't ask you to know that. We'll only go up to decane, but for the purposes of this exercise, I just wanted to add it in here. And then we can see we have one of our main substituents here, right? So we have this one right here, and then we will want to identify the longest chain of the substituent, right? So that's the longest chain of the substituent here. And then if we count this out, this is 1, 2, 3, 4. And so that's butyl. And it's on the 6th carbon, right? So this is kind of 6-butyl something, right? But then we can see that this compound or this chain has a chain on itself, right? There's yet another substituent. So we've got a substituent on a substituent. And so what we do for this is basically just make a subset of the name. We see that we have this one on the 2nd carbon of our butyl chain, and we see that it's a methyl substituent. So this is 2-methyl right there, right? So this is 6-2-methyl-butyl undecane, right? There's that compound right there. So you can see it can get quite complicated. One last little thing to add is 2 random substituents to memorize. And so basically these are just common names that IUPAC still kind of recognizes as these are so common that we can't get rid of them. So we might as well memorize them. The first chain is this isopropyl. Which you can kind of think of this as a 1-methyl ethyl substituent. And then the other one that we want to know is this tert-butyl. Right, and so this is where like kind of the rest of the parent chain would be. You can think of this as kind of dimethyl ethyl. And so all of this stuff is honestly just practice. Just practice, practice, practice. And remember, I'll always give you the name and ask for the structure. We won't go the other way around. So you don't have to memorize all these tiny little rules. You just kind of have to have a good general understanding of it, right? It's a lot easier to read something than it is to write it.